Hi, and welcome back to the Bootcamp series. We have successfully made it through the first set of modules, which are all about the very basics of using R, how R deals with data objects, how to manage data, how to read data in, how to do some basic visualizations, basic statistics, and computer programming operations. And so we have basically made it through really the core of what you need to know to get started with R. So we've made it. But let's move on to Bootcamp 2. So we're going to move a little bit beyond the basics with these next set of modules and hopefully give you a sense of where you can go, because there's a lot of cool places to go with R. And so we're going to go a little faster and kind of do a tour of what R can do beyond the basics. So let's start with submodule 2.1, R packages. So first of all, even if you don't go right ahead and use a whole bunch of advanced packages, there's a lot more to do in base R. So in order for you to do what you want to do, to work with the data that you have, you're going to have to learn additional skills in R. So hopefully this has been a good introduction to the basics, but you're going to have to go further. One of the goals here is just to get you to the point where you're comfortable enough to go off on your own and learn new things and new skills. And so one point about R is that R is so flexible that there's almost always a way to do something in R. It's not only flexible, it's powerful. There's so many tools at your fingertips. Whether you use base R or whether you use packages, which we'll talk about in this module, there's almost always a way to do it. So that gives you a sense of confidence. You just have to know where to go to find help, to find additional tools that you might not be aware of, additional functions, and additional packages. So let's talk about packages, because one of the things that intentionally we didn't do in the first set of modules, this Bootcamp 1, we never loaded any packages. We used the base R package, which you get when you install R, and we just were using the functionality that you get in base R. So what we're going to do in the second set of modules is we're going to start using packages. Every one of these submodules uses different packages, and packages are just additional sets of functionality that people from around the world, statisticians, scientists, anyone can contribute to the R project, and people have in incredible numbers. And basically writing functions, we talked about how to write functions in the programming module. Now people have taken advantage of that, and you can actually package a whole set of functions into something called a package. And you'll see that most scripts that you see other people write and you download from the web, most of them are using some type of packages. So it is really important to know how to use packages and how to get help with packages, how to learn more about them. So that's the point of this module. Before we get into the module itself, let's make sure we get the R script. So just right click or control click, command click, whatever it is on a Mac, and save this to your working directory. All right. And then we can move into our studio. And when you go into our studio, let's just open up the R script we just downloaded, and that should be module 2_1.r. And here we go. Expanding R functionality, packages. So as an example of the use of an R package, and there are thousands, there are tens of thousands of R packages out there that do any number of data visualization or statistics or modeling tasks. There are packages developed from almost any discipline you can think of that deals with data and performs almost any kind of task that you can think of with data. So it's just incredibly powerful. It's worth kind of taking some time just going through randomly through the Cran repository and just getting a sense of how incredible these tools really are. And when we think that so I mentioned the Cran repository, that's the main repository. That's kind of the repository for official R packages. We can actually maybe take a quick look at the R Cran repository, and you'll see it's called, and this is where you went to download base R as well, but this repository also stores all these packages that people have submitted from around the world. And so it's the comprehensive R archive network, and you don't really have to know much about it because RStudio is really good at interfacing with the Cran repository, so you barely even know it's there. But it's good to know that that's the official repository. So when you install packages using the install.packages function, or if you go to the packages tab in RStudio and hit the install button, you are by default installing from this Cran repository, and you're probably installing from some mirror of the Cran repository that's located near-ish to where you are. The easiest way to install packages is just to use this RStudio interface. I'll do it one more time just so you see what you need to do. So go to the Packages tab here and just hit Install, and then type the name of the package that you would like to install. So the package that we're going to install first is called modest. Now, in the earlier modules with base R, we've computed the mean and the median of data vectors. One thing we haven't done is computed the mode, and one reason for that is that there is no function for the mode in base R. So to expand the functionality of R and to include this new function of the mode being the most likely or most frequently occurring value in a vector of data, we're going to need to install a package and use functionality that other people have contributed to the R project. So let's do that. The package is called modest. So let's install it and you'll see that RStudio will try to guess what we're typing in, and we see that modest is there. So let's install that package. Now, packages only need to be installed once. Once you've installed it, it's kind of a part of your R installation, and if you want to access the functionality, all you have to do is use the library function to load up all the additional functionality that's in that package, mostly just additional functions that you can use. So once you've installed a package, you don't need to install it every time you run the code. So I'm going to comment it out in the R script so I don't have to run it again. And because sometimes installing packages actually takes quite a while. We'll see if you try to load the tidyverse package for the first time, you'll see it can take a long time because there's lots of other packages that the tidyverse package depends on and has to be installed as well. So we have installed this new package. All right, so now let's explore the package. So, the first thing we want to do almost anytime we want to access functionality from a package is to use this library function to load the package. So now we've loaded the functionality and we have access to all those, all the cool new features of this package. So let's explore the package. We can get an overview using this syntax. We use library again, but now we say help equals, and in quotations we say modest. So this asks R to give us an overview of this package. And when we do that, we see it pulls up this thing called documentation for package modest, and it gives us some details about what version of the package we're using, who the authors of the package is, and a bunch of information about the package itself and when it was compiled, but also gives you an index of the functions that are included within the modest package. And if you want, let's say we want to compute the mode of a vector of data, we can try to guess which of these is the right function to use just by looking at this documentation. And some of these seem pretty specific. These are different estimators of the mode. Clearly, there's not just one way to compute the mode. And then there's this MLV, which says estimation of the mode or most likely value. So that's a pretty promising lead there. So perhaps that's the function we want to use. Modest is the name of the package. Looking down, doesn't seem like anything else. So it looks like MLV is the function that computes the mode in this package. So let's go back to our script. I can get rid of that documentation for now. And let's see how we can compute the mode. So let's read in a data file. Let's just randomly we'll read in the data missing sample data file that we've used in the past. So let's read that in. If you haven't already downloaded that file, you can get that data file by going back to the website and finding where it says here, download. Let's try to use it. If you haven't already loaded the missing data set, download it here, right click here and save it into your working directory. Let's go back to RStudio. Let's learn a little bit more about the MLV function. So remember, just preceding the name of a function with a question mark allows us to get the help file. So let's get the help file for the MLV function. Now we see that MLV belongs to the package modest, and we can get documentation for base R functions or functions that are in packages that we've loaded just by using that question mark. So we can learn a little bit more about the syntax for getting the mode or for computing the mode. We won't go through this whole thing, but you can read it if you'd like. You see the basic syntax is it wants some data vector, some indication of what to do if we have NAs. Do we remove the NAs or do we not remove the NAs, just like the mean function in base R? And it also wants a method. So if we give it a method, there's multiple ways to compute the mode, and we can see that there's several methods available, and we could specify any of these and potentially get a slightly different answer. That's not the point here. The point here is that we can now compute the mode because we now have that function. So let's take that syntax. We're going to use the export function, and we're going to compute the mode of that vector. We're going to use the MFV function for most frequent value, and we're going to remove NAs. Okay, and let's run it. And the most frequent value is 0. Let's look at that. Does it make sense to us? It kind of looks like 0 is probably the most frequent value. We could use the table function on the new df export, and we see that there are 3 zeros, and that is the most frequent value. So it did give us the correct mode in this case. All right, no further need to look into this. Just a quick introduction to packages. Let's get this. You don't always need to do this, but if you don't want the functionality in a package anymore, you can remove those functions using the detach function and say package : the name of the package you want to remove, and that just removes the functionality. So now modest is, MLV is no longer found in our workspace. It's just not there because we've detached that package. All right, so now let's move on to a different package example. This one's kind of cool. It just illustrates the kind of visualizations that you can get by loading some packages that aren't part of base R. So we're going to use a plotting feature for interactive plotting that's available in the companion to applied regression package, CAR, C-A-R. So first, let's load some data that we want to make sense of and visualize. All right, so the data is, we're going to have 3 different vectors we want to look at. So we're going to look at a 3D relationship. Essentially, we'll have 1 response variable and 2 predictor variables. The response variable is the number of dog barks in a day, all right? So this is 15 times the dog is barking in that day, 12 barks per day. You get the picture. And we have some two covariates that could potentially explain, or explanatory variables that we hypothesize could be causing the dog to bark. One is food availability. We might hypothesize that the more food the dog has, the more satisfied it is, and the less it barks. We also have the number of cars going by. So the number of cars going by, we might hypothesize that the more cars going by, the more the dog is going to bark its head off. So let's read in these vectors. All right, 1, 2, 3. And now we have to install, if you don't already have these two packages, car, companion for applied regression, and RGL, which I don't know what it stands for, but it's also necessary to do this, what we're going to try to do. So if you don't already have those, install them. You can either use install packages or go to the packages tab, and you can install both at the same time if you want. You could say car and then space RGL and just hit install, and that should install these two packages. I already have them installed, so I'm not going to do it right here. And now that you've installed the packages, let's load them onto our current R session using the library. Actually, we just need to load the car package in. So we'll use library function and load the car package in. And now we can do this kind of cool 3D interactive graphics. We can use this scatter 3D function from the car package. Now, what I'm showing here is that, well, first of all, we can run this because we've loaded the library, so we should be able to run the scatter 3D function right away. Another way to be really explicit about calling functions from packages is to use the syntax. You start off with the package, 2 colons, and then RStudio will by default just show you all the different functions that are available to you. And we could scroll down. You see there's a lot of functions in this package. We could scroll down to scatter 3D and do it that way. So then we could just fill in the arguments for the function. And so it's the same thing, but it's a little more explicit if you want to make it really clear that you want to call this function from this package. Sometimes functions have the same name in different packages, so it's really important to know this syntax so that you can make sure that R is using the right function from the right package. The other thing to know is that you don't actually need to use the library function. If you use this way of calling functions, you don't actually need to load the function into your current R session, because you're basically telling R that I want to grab this function from this package. So just something to know. It can come in handy. All right, so let's run this line. It's loading some packages, and now it pulls up a graphics device. It actually throws a new graphics window up at us, and we can make it a little bigger so we can see what's going on. But what's cool is that we can play around with the 3D graphics, so we can view it from different angles just by clicking the mouse. And let's see, what's a good angle for this? I don't know, something like this. We can at least see that the cars variable is definitely driving the number of barks. There's more barks when there's more cars. And let's look at the food axis. As there's more food, there's fewer barks, as we would expect. So there we go, 3D graphics. And I'm only showing this because it's kind of cool. There's just hundreds of thousands of different things I could show you, and obviously I'm not going to go through too many examples, but just a couple cool examples. Now, I mentioned the Cran repository earlier because that is the official repository for R packages, but it's not the only repository for R packages. You will find packages that are in other repositories, and it's useful to know what those repositories are and how to grab packages, groups of functions from other repositories. And specifically, the other repository to know about is Github. GitHub is often used by developers who are just making a package and aren't quite ready for prime time. They don't want to put the package up in Cran, which makes it more official. Let's quickly go back to the website and review the rationale that developers use for using GitHub and not something like Cran. There are some good reasons to use GitHub instead of Cran from a developer's standpoint. First of all, it's easier for others to look at your code. GitHub is, it's the most commonly used code repository, and many people know how to use GitHub, and they can basically just go there and look at the code. People can fix problems in GitHub and send you a requested change. It's pretty easy to do in GitHub, and so if people are using your code and it's not finalized, you're still fixing bugs, other people can basically, instead of saying, hey, there's a typo here, or there's a bug here, they can fix it for you and then say, hey, here I fixed this. You can use it or not use it, but here it is. It makes it really easy for rapid development. So developers love it, and it's still easy to install packages. We'll show an example in a second, but you can use this install GitHub function, which is itself in a different package that's on Cran. And we can use that function to install packages that are on GitHub. So it's almost as easy as installing packages that are on Cran. But most of the time, developers will often have both versions. They'll have a Cran version that's sort of like the official version of their package, and then they'll have a GitHub version that is in development. So if you want to get the latest features from a package, oftentimes you'll want to get the GitHub version because it has the newest version, the newest functions. So it sometimes comes in handy to be able to install packages from GitHub. All right, let's go back to RStudio and we can try this out. Now, if you don't have the DevTools package, you'll have to install it first. I already installed it on my computer, so I'm not going to do it again, but take a second to do that if you haven't done it, using either the packages tab here or just the install packages. And once you've installed it, you can comment it out, and then you can load you can load the DevTools library package, and let's install a random package from GitHub. Now, I cannot for the life of me remember what this does, but we can use this. We can install the Broman package from the user kbroman, and hopefully it will install for us. There we go. All right, so I got an error, and the error says that I don't have the latest version of RTools, which is it's a set of software that you need to do development of R packages. And so I think I need that to run this install GitHub properly. So I followed the instructions on this error message, which is a nice error message because I can kind of interpret what it wants me to do. It says go to this website and download this new version of RTools. So I went to this new version of this website, which is here, and downloaded the version of RTools from my machine. So if you need to do this, feel free to do it, or just know that you could do it, because we're not using this package for anything. I'm just sort of demonstrating that you can get packages from GitHub. So if we go back here, and I should have the DevTools already loaded. Let's try it again and see if this works this time. Let's hope. It's downloading from GitHub. Now, clearly, loading from GitHub is more likely to run into errors than loading something from Cran. Looks like it wants me to potentially update some packages. I'm just going to say none, so I don't want to update anything. And it looks like it's doing something. It's gotten further than it did before anyway. And it's checking the results, and it is done, I think. Just about. Well, okay. So the point I was making earlier was you're more likely to run into errors loading packages from GitHub than you are from Cran. So I would recommend if a package is available on Cran and the functionality is fine, just load it from Cran, because that's kind of the official repository that's been checked and everything is compatibility checked, and you shouldn't run into too many problems. GitHub, on the other hand, is a little bit more of a Wild West situation, and you don't know what you're going to get. You don't know what errors you're going to run into. So it looks like it did work in this case. So just following the error instructions from the error I got earlier, I was able to solve this one and was able to load this package that I can't remember what it does, but that's not the point. Okay. If you want to learn more about packages, oftentimes you don't necessarily have a great idea what the package does and you want to learn more. Obviously you can go to the documentation like we saw before, so using the syntax for if I wanted to get help on the companion for applied regression or CAR package, I can get that information and see information about the authors and all the different functions that the CAR package gives us, which are quite a lot. You can visualize this. There we go. So that's one way to do it. You can also, one of the cool things that a lot of packages provide is a vignette, which is like a PDF that it's kind of a worked example of a simple use case of this package, and often comes in really handy. We can see that there's a vignette for the CAR package, and it's called embedding. So if we want to look at that, we can. Let's go back to the module. So the vignettes, you can also browse the vignettes using this convenience function, browse vignettes, and this will give you access to any vignettes. Now there's just one vignette for the CAR package, and it's this embedding vignette. So there you go. It can be kind of useful because it just kind of walks you step by step through the code and how to use it, or through the package and its functions and how to use it. So kind of useful. You can also, since we saw in the documentation at the bottom, there's usually information about the vignettes. This one's called embedding. So if we go back in here, we can pull up that vignette by saying, I want this vignette from this package, and it'll pull up the PDF directly. All right. Let's go back to the website, and we can talk just a little bit more about how we can learn how to use packages using these various documentation that's usually provided along with packages. So one example from the Dismo package, which is a great package if you do species distribution modeling, so Dismo for distribution modeling. You'd have to install and we don't have to go through that right now, but you can install Dismo, browse the vignettes. There's several really useful vignettes, and just take a moment to walk through one of those vignettes, because I think, especially if you're ever interested in doing species distribution modeling, it just really helpfully walks you through how to do like a whole distribution modeling analysis in R. So take a look at that one. Some packages, in addition to vignettes, or instead of vignettes, provide something called demos, which are worked example that is just fully in R code. So once you run the demo, you'll see a bunch of R code flash in front of your eyes, and look back and kind of run through a complete worked example. We can do that. We can run that here with the stats package. So we can run through, well, first we'll list all the demos that are available in the stats package, and we can just pick one and run it in our R script here. we pick the NLM for like nonlinear modeling and just do a demo, and we can kind of walk through these different steps of a nonlinear modeling. There we go. There's a contour. So again, I'm not going to go into great detail here, but it's just an example of what the kind of help you can get from packages. So those are demos. Package documentation is often really important to look at. The first thing to look at is usually the PDF file that is often loaded with the package, or you can often find these PDFs just by a quick Google search of the package. Here's the PDF that comes with the raster package right here. And there we go. And it's a pretty extensive documentation here, and we'll take you through all the different functions and what they do, and basically puts all the help files together in one place for all the functions from the package. So these are often really useful documents for finding more information about packages. Another useful thing to know is when you are within your R session, you can do help.start, which will give you access to all the documentation for base R, but also for all the packages that you've loaded. So if you look at packages, you can see an index of all the packages that you have loaded on your computer, and say find one, and you can get the help files basically for all the functions that are within that package. So just useful things to know about getting more information about packages. Now, pretty much every function that is either in base R or in a package will have some kind of examples included in the help file. So if you type the question mark LM for linear models, that's in base R. Well, stats, which is part of the base R package. You'll see that there's some examples at the end. So these are use cases, can be really useful, but oftentimes a little less useful than you wish. But if you want to run those, you could, of course, just copy and paste right into your R workspace, but you can also use example, the example function, which pulls the example from the help file out of the function, and you can see that it's going to run the same lines of code here. So these lines of code are reflected over here, and it's going to ask us to hit enter to see a plot, but just kind of useful to know. But I would say that the examples are often less helpful than you think they should be, and if you want to get a more complete example, try to find a vignette, or maybe just search Google for some examples that may be more within your field or just make more sense to you. So don't just think these are the only examples available to you. You can find probably better examples on the web. If you use a package, you probably want to cite the package in any paper that you are writing with the results that you are getting from a package that you used, especially if the package is providing some really important functionality for your paper. You can just use the citation function, and it'll give you the suggested citation for any package. This happens to be for the car package. You can also do that for base R. Now, if you're using R for doing your analyses, you should probably cite R as well. You should not probably, definitely cite R as well. And here's the citation for the base R package. All right. Let's go back to the website. Just a few more quick notes about packages and going further with R. Online forums are definitely your friend. It's amazing how many people take time to answer questions in online forums. So when you Google search an R issue that you're having, oftentimes it'll direct you to some of these online forums like Stack Overflow, Cross-Validated, so on and so forth. You'll see those as you start searching, and you'll see that there are people just responding to other people's questions in often great detail, and using those responses can be really helpful in your learning process and trying to figure out how to do new things in R. So take advantage of those forums. Of course, if you can't find anything, any answers with a Google search, going to these forums, you can ask your own question in these forums. Just make sure your example, your question includes code that allows any problem to be replicated right away, because people don't want to spend extra time just trying to figure out what problem you're having. So it takes a little time to get used to how to post to some of these forums, but in a pinch, when you can't find an answer elsewhere, it's great, and you'll get an answer, and it'll probably come pretty quickly. All right, if you're still struggling, you can reach out to the package authors. So oftentimes the authors are very willing to entertain questions and issues from users. The authors, you can find the author just going to the library help equals car, for instance, and get the documentation. You'll see the authors there, and you'll also often see an email address for the maintainer. So here you have this is the person you would probably want to contact if you want to ask a question about the car package. So again, really useful, maybe a last resort thing, but most authors are really incredibly willing to answer questions, and often will get back to you quickly. I would recommend downloading some cheat sheets, taking advantage of these cheat sheets, because if it's a commonly used functionality, whether it's base R or any number of really commonly used packages, there may be a cheat sheet that's available for you to download and study and use. It can make your life a lot easier. Just at your fingertips, you know now how to do all sorts of things just in a couple pages. There's several cheat sheets that are in the links page for this bootcamp, so you can just go to the links page up here and find some of these reference cards or cheat sheets that you can print out and keep by your side if that helps. All right, let's go back to the main R Bootcamp website, and just want to end by saying, don't be afraid to use Google to search for answers to questions in R. It's just amazing. It's hard to believe that it works so well, but especially since R is just a single letter, so it somehow, if you put R next to a statistical question, it gives you R-based results. So it does an amazingly good job at giving you good answers. And just don't forget the basic idea of solving issues with computers. Just keep trying. Sometimes it feels kind of random, but try new things, do a Google search, see if something works. If it doesn't, go back and search again, and you'll find an answer. The answer's out there. Somebody's probably given a great answer out in the World Wide Web somewhere, and you just have to find it, and just be patient. And that's pretty much all I wanted to say about packages. I'll see you in the next video, where we'll talk about the tidyverse, a set of packages that are commonly used for data science. I'll see you then.